Hello and welcome everyone in another episode of Researcher Celebrity. Today we have Professor Scott Weaver with us. We are delighted to have Sir on this platform where he is already the torchbearer in field of entomology, immunology, and immunity of various infectious diseases. A brief introduction of Dr. Weaver. Professor Weaver has done his college in Virginia and then went for master's in Cornell University, where he studied entomology. And for PhD, he did UC. He had joined UC San Diego, and now presently, sir is director of Institute of Infections and Immunity, and also chair of Department of Microbiology and Immunology. With this brief introduction, I would like to welcome Professor Weaver at this platform. Thank you very much, sir.
Thanks for the invitation.
Yeah, so we start the conversation that how and when you decided that you wanted to be a researcher.
Well, it really came about gradually, mostly when I was in college. I was interested in science before college, but I didn't know exactly what pathway I wanted to take. And I really just stumbled into the first line of research that I was involved with, which is mosquito biology, because when I was finishing my first year of college, I was looking for a summer job. And I found a very good position just about a mile from my home, working for the state of Maryland mosquito surveillance program. It paid pretty well. It allowed me to get outdoors, to see different habitats around the region. And so I began getting interested in mosquito biology first. And I did a small project on mosquito ecology for my undergraduate degree. We had the option of doing an honors thesis. So I did a project on mosquito biology. One of the faculty, we had one entomologist, William and Mary is a small college. But he really took me under his wings, was a wonderful mentor for me, helped me get that project planned and implemented, and then published in the end. And also encouraged me to go pursue entomology through a graduate degree. So he advised me to apply to a few of the best programs in the U.S., and Cornell seemed like the best one for me. So I started out there. Kind of the way that I ended up working on viruses is that my entomology supervisor had a collaboration to work on Venezuelan equine encephalitis with a virologist who was at the medical campus. Cornell has its medical campus in Manhattan, and the main campus is upstate in Ithaca. But he arranged for me to spend a year down there. The names of these individuals were Ed Cupp, the entomologist, and William Scherer, who was the virologist and chair of microbiology at the medical college. And he needed somebody to help him start doing experiments to look at the ability of mosquitoes to transmit these viruses. And I had the mosquito experience, and he taught me the virology. So I did a lot of my work there, and really would have continued with that for my PhD. But William Scherer died suddenly during my second year of graduate school. And I really, in the long term, I didn't have the ability to continue that work because of the containment requirements. And he had built specialized facilities, but they were hiring a new chair who was very unlikely to continue that kind of work. So I took some time out. I worked at a hospital in New York doing electron microscopy in a pathology department. This was near the Cornell medical campus, so I was able to finish a few things up there. And then I decided I really wanted to finish my education with virology to complement my entomology background. And I did that working under John Holland, who was really one of the pioneers in the rapid mutation rates and potential for rapid evolution of RNA viruses. So I worked with him for my PhD, and then I stayed one extra year in San Diego while my wife was completing her training, and then we came to Galveston 28 years ago.
So just when you completed your PhD and moved to Galveston, since then it's been almost 3 decades. What were the research areas which you thought when you completed your PhD that you would pursue, and how that has changed over these years?
Yeah. Well, what I really wanted to do was to find a university where I could work both with mosquitoes and arboviruses.
Mm-hmm.
When I was in San Diego, there were no facilities for working with mosquitoes, but I wanted to learn mainly virology there anyway. But I really wanted to get back to working in both areas.
Mm-hmm.
And here at UTMB in Galveston, David Walker was chair of pathology at that time, and he had a commitment from the administration to renovate a building on campus called the Keeler Building.
Mm-hmm.
And he was about halfway through that renovation, and he obtained, through some philanthropic support, a commitment to hire 6 new faculty and start a Center for Tropical Diseases.
Mm-hmm.
And there was an advertisement. I was just looking for faculty positions, and I saw an ad. I didn't know anything about UTMB or Galveston, but the ad stated they were looking for scientists. Really, the top priority was to look for other scientists working on intracellular bacteria,
Mm-hmm.
because Dave Walker is a world-renowned rickettsiologist, and he really wanted to increase intracellular bacteria in the department. But he said that they would consider any other areas related to tropical diseases. So I applied anyway, and it turns out that I guess he didn't find exactly the people he wanted for bacteriology, but I applied, and also a friend of mine who had been helping to fund me for that one extra year in San Diego, named Bob Tesh, was not very happy at Yale University at the time. And so he was looking around, and I found out just by talking to him on the phone one day that he had applied for a job here too.
Mm-hmm.
And so this made it even more attractive to me, the possibility that he might come.
Mm-hmm.
Although I had to interview and make my decision before he did. So I came down and looked around. Dave Walker had very good resources put together for the center. The facilities looked like they were going to be top flight. He was willing to build me an insectary to keep mosquito colonies going and to do experimental infections, and offered me a very generous startup package. So it seemed like a great place to come. I hoped that Bob Tesh would come, but I couldn't wait for his decision. So fortunately, he decided a few months later that he also accepted an offer. So I arrived late 1994, and he came in April of 1995. And then to make it even better,
Mm-hmm.
his very close friend and colleague, Dr. Bob Shope at Yale,
Mm-hmm.
was deciding what to do, because they had a program there called the World Reference Center for Emerging Viruses and Arboviruses, a huge collection of zoonotic viruses dating back to the 1950s, originally developed by the Rockefeller Foundation when they had overseas labs in many parts of the world where they were looking for viruses causing human disease, especially arboviruses. And so the two of them at Yale ran this reference center, and they had a bit of a dilemma what would happen with it if one of them left and one stayed. And so Bob Tesh convinced Bob Shope that he ought to consider coming down to Galveston too.
Mm-hmm.
And Dave Walker created a position for him. So Bob Shope came about 6 months after Bob Tesh. So here I was a very fortunate young person to land at a place where I had these two world-renowned mentors who were just wonderful to me,
Mm-hmm.
and really 3 mentors if you include Dave Walker, who was also a great mentor for me as my chair for 20 years.
Mm-hmm.
And so I landed in a place where I had every advantage of great mentoring, all the facilities I need, and just worked out extremely well for me. I was able to get grants going fairly quickly to establish a lot of research in Latin America
Mm-hmm.
on Venezuelan equine encephalitis virus, and I've stayed all these 28 years just because there have always been a great group of colleagues and collaborators to work with here, and we've always had the best facilities to do any kind of high containment studies, including with mosquitoes and other arthropods.
Nice. So, Professor, we were here at Researcher Celebrity. What we try to do is like we try to give a 360-degree view to the researchers around the world. So, coming from you, there's like when you are mentioning about the role importance of collaborators and networking, as you mentioned few names in there. So what are your suggestions or your recommendations, I'll say, to the young researchers who are looking for faculty positions or who just joined as a early career fellow, that what they should do to build this network?
Well, so it was much easier for me than it would be for most people. So ideally, they find an institution where there's some senior people who have international connections and collaborations who would help them to do that. But these days, at many universities in the U.S., there's a big focus on molecular biology and laboratory work, not so much on the kind of field work that I've done over the years. So it's tougher to find that kind of environment. Um, but it is a lot easier than it used to be to network through social media, online conferences, and in-person conferences too, to find those kind of collaborators to build that kind of network. And the other suggestion I have is there are a lot of special programs here in the United States that are designed to build collaborations between US scientists and those from other parts of the world, especially endemic areas for many infectious diseases that are major threats around the world. So I think the Fogarty International Center, for example, it's part of the National Institutes of Health here in the US, has special programs. Even the National Institute of Allergy and Infectious Disease has set aside money for international scientists to apply for funding. And I think if you're willing to reach out and make connections and then help scientists from other countries adapt to the US funding system, there is money available, and you can develop very nice programs. Some of the first grants that I got to work in West Africa, where most of my focus is now, were very small grants offered through the Fogarty Center, where international scientists could apply for money to come to the US for about 6 months.
Mhm.
And so I had several of these successful applications, and visitors from Senegal, for example. I had several from Senegal, also from Latin America. And that really, the ability to spend time together for those 6 months really catalyzed great long-term collaborations in those countries. And so it's not easy, but you have to invest, I think, in helping international scientists adjust to the US funding system. Probably very similar if you're working in other parts of the world where the funding mechanisms are always a little bit different. The culture of the review process is always a little bit different. You have to invest in helping other scientists to navigate those systems.
Yeah, and think this will be very helpful for all the researchers around the world because when Professor Weaver is saying something that about these funding opportunities and all, you guys should just open up your horizons and then just don't limit yourself to the countries where you're working. If there are opportunities and fundings available, you should just try to tap into. And we have mentors like Professor Weaver also just mentioned that there are mentors who are ready to help you. It is just like you have to approach to them and then just enjoy your research the way. So, Professor Weaver, uh, you just briefly touched upon like the field work as most of the entomologists, which they used to enjoy a lot. And now biology is going mostly into the molecular biology. And a couple of months ago, we have Professor P.K. Rajagopalan as our researcher celebrity. So he's the person who figured out the reason for KFD in India. That's a very small uh, pockets where this disease is there, Dinosaur forest disease in Shimoga district of India. We in our conversation it came up that he said that the race of the entomologist is going to an extinct species soon. What are your thoughts about that?
Well, it's very tough to do international field projects now, and it keeps getting tougher. And the reason is that the regulations on importing and exporting samples are more and more strict, and they often don't make any sense scientifically. I'll give you one example.
Mhm.
I collaborate with a virologist in India on chikungunya virus, which is a big problem in India, a smaller problem here in the US, but a big concern too. And um, we have this World Reference Center, huge collection of viruses. We have a lot of chikungunya strains, a couple of hundred. If I want to send my collaborator in India a strain of chikungunya that originated in India, maybe in the 1960s or something like that, I have to get a permit from the US Commerce Department to export that to her. And
Mhm.
it takes several months of waiting for them to act. Then they have to review the facilities in India. And this just makes no sense. Chikungunya is endemic in India. It's been there for a long time. There are a lot of outstanding Indian virologists who are very experienced working with chikungunya. So there are a lot of these kind of regulations that unfortunately there's no opportunity for scientists to have much of any input. They're
Mhm.
made by people without scientific knowledge, and other examples, include importing samples into the U.S. from around the world is equally difficult. Just the shipping costs now. We have a major program in West Africa. We do a lot of shipping of samples back and forth. The last shipment we made, one large box, not hazardous material, just dry ice and sera and mosquitoes and things like that, cost $6,000 US. So it's just getting very, very expensive. We also have in the US regulations surrounding something called select agents.
Mhm.
These are particular viruses, bacteria, toxins, and fungi that can be used as biological weapons. And to work with these, there's major levels of oversight from the federal government, record keeping. When we send to a collaborator within the U.S. here, one vial of a select agent, it costs us about $10,000 because of the security requirements. So it's just getting more and more difficult to work with many of these agents internationally. And unfortunately, it's a very difficult problem to solve because when anything goes wrong anywhere, or there's discussions about how viruses arose, the knee-jerk reaction is let's just put an extra layer of regulations and compliance on top of it to make things safer. But at some point, that is counterproductive and just reduces the efficiency of the work, makes it very hard to make any progress. And as we all know, the next pandemic is not likely to be started by a virus here in the US or even, Europe or many other parts of the world. It's likely to come from the tropics, countries that tend to have limited resources. And if we simply make it impossible to work collaboratively with those countries, we're going to be less prepared in the future.
So the role of this collaboration, and nowadays when we have access to internet, to all the social media, where people are started talking about one world, one health, keeping these pockets and not collaborating is, as you mentioned, is counterproductive, obviously. But now when people start thinking about synthetic biology and doing something that there is something which is not even existent and we can make it now, as a researcher you have evolved and now you have so many administration responsibilities also. How do you think that or what are your thoughts about synthetic biology, or how the research should be regulated?
Yeah, that synthetic biology has really added a new layer, a major new layer to the complexity of these questions. And, I think that to some degree, some countries can regulate this very well. If I, for example, let's say I want to make a cDNA clone for a virus that I work in, maybe it's chikungunya virus. if I request that synthesis to be made by a company here in the US, they ask me a lot of questions and they may outright refuse to do it if they're concerned about it. It would be even tougher, I think, for things like SARS coronavirus 2 or Ebola virus or things like that. But in some parts of the world, I'm sure that's not the case. And it doesn't take much more than a small garage to set up an operation to synthesize DNA these days. And so it's very tough to regulate internationally. And I think we scientists really have to put our heads together and figure out the best ways that this can be done and advocate for reasonable international standards for biosafety and biosecurity. I think having more uniform standards would help a lot, both to reduce risks and to assure the public that we're doing everything we can to maintain safety. But in the end, it's becoming more and more difficult to have airtight systems to prevent somebody from synthesizing a viral genome and rescuing the virus and doing whatever they want with it. And I'm afraid that that problem is just going to continue to grow because the work's going to become more and more inexpensive with the technological advances. And there are a lot of scientists in parts of the world that they can't get funded through legitimate ways to do science, and they may look for the wrong routes to doing science that's too dangerous.
Yeah, so this brings us to the moral and ethics of science and research. So in your like over so many decades, you have worked in US and internationally also, you have collaborations on so many countries. When you talk to a researcher about a research question, which might or might not have a moral or obligations toward the society, what you have seen and how you see that thought process has been changed over these decades.
Well, I think this is another, I think, positive development is that scientists, and I think in part due to our experience with SARS-CoV-2, the COVID-19 pandemic, I think we're recognizing more and more that it's our responsibility to learn to communicate effectively with the public and with our elected leaders, politicians, very few of who have any scientific background. And so, for example, with our graduate students here at UTMB, we're putting more and more emphasis on training them to communicate with non-scientific audiences, to prepare what we call elevator speeches, a very short description of what they do scientifically and why it's important to do and important for the government to support through tax dollars and research funding. And I think that really needs to happen around the world. We have a training program. This is a Fogarty Center grant for bringing young West African scientists here for up to 6 months. And then we work with them in their home countries too. And one of our major goals is to train them to communicate with their home populations about what they do, why it's important, how they're making it safe for the communities where they work, and why they're helping to protect public health internationally through that work. And I think this has to happen really everywhere in the world.
Yes, that's a great initiative. And I think this is the way also for the future research, that when everyone come together and work towards the same goal and be prepared for the situations, or either it be epidemic or anything, because as you mentioned, the tropics are with the limited resources have this potential to give something which if we are not prepared, then it will be a very major loss to human health also. So now you just mentioned about the graduate research students. So speaking of which, when you completed your PhD and now so many students have the fortune to have you as a mentor for their PhD programs, how you see a PhD student, a researcher, way back like 4 decades ago when a person just joins the PhD? How was that life at that time? And now when you see a PhD student approaches you or for the PhD registration, and then how the study goes?
Yeah. Well, I think the culture here in the United States has changed a lot. And I can't say this applies to me personally because I was extremely fortunate to have mentors who allowed me a lot of flexibility with my personal life. And for example, when I started my PhD, I had a 1 month old daughter, and my wife had just finished medical school and took a year off before doing her residency training. So I had a year to really hit the ground running, get my dissertation research moving quickly, get through my courses. But the second year, I was the one doing most of the child care because she was in the hospital every third night, and then she was recovering in between by sleeping most of the time. So I had a mentor who just gave me tremendous flexibility. He didn't care as long as I was progressing and doing well, what hours I was in the lab. But I think in those days, a more typical situation was research faculty research mentors expecting students to work very long hours and doing a lot of micromanaging. And it was a pretty tough period of time for most students. I think it's gotten a little bit better in that sense. I think that especially with attempts to diversify the scientific workforce, to get more women into science, I think that the expectations have become more reasonable, and I think there's more flexibility now. So I don't think there are quite as many tyrants who are running labs, training graduate students as there used to be. And I think the culture has put pressure on people to give students more flexibility, to recognize that they have lives outside of science that are equally important to them, and that their success in the long run as a scientist depends on keeping their family together and balancing their personal and scientific lives. So I think we've improved quite a bit with that. The same is true for faculty as well. We have a lot of programs on our campus where we try to help young faculty, especially women, but also men, may have major roles in the family, to find the right balance between their personal and scientific lives. And I think that has served us very well overall.
Nice. So speaking of this, we still there are few incidences which is either in USA or in India. What we have seen is like PhD students are quitting PhD after 3, 4, or sometimes in 5 years. There are cases. In fact, India, we don't have a lot of counseling, and in some very sad cases, people do commit suicide. So, what are your suggestions or guidance for the PhD scholar who's going through a rough patch in their life?
Yeah. Well, I think first of all, before even going to graduate school, for some students, it's probably a good idea to work for a couple years, um, especially if they can experience a laboratory that's training students and they can see what the requirements are, what the pressures are, and really understand what they're getting into. Some students, I think, get a lot of experience as undergraduates in a lab and may not need that extra time. But there we have a program here on our campus that's specifically designed to take students after their undergraduate studies and give them 1 year in a laboratory. They work as a technician. They get paid, not a great salary, of course. Science is not known for the highest salaries, but they get paid a salary where they can have a reasonable quality of life. They experience what it's like to be in a research lab that's training students and postdoctoral fellows. They get a lot of mentoring and preparing for applying to graduate school if they make that decision. And I think that those kind of programs would help a lot more students. We simply don't have enough funding to offer that opportunity to everybody. But I think that's a good alternative for some people to just going straight through from their undergraduate to graduate school without really understanding completely what science is about. I think the other problem we have here in the U.S. is that a lot of the students, especially the ones we really want to get into science, come from backgrounds where neither of their parents have gone to college at all. None of they're first in their family to go to college, and their families don't really have much idea what scientists do. And I think that culturally, we have to, again, back to educating the public, we have to make it easier for families to understand what does a PhD do for you? What do you do with a PhD for a career?
Mhm,
How does it what we do in a research laboratory relate to when they go to the doctor's office
mhm,
and the physician or other healthcare providers making decisions based on basic science done in labs like ours? And so I think getting the public to understand the scientific process, the funding, and so forth would help quite a bit with some students who really don't get the support they need from their families. And when they run into a rough patch, and as we all know, it happens to everybody, your experiments are never going to work for 5 years straight.
mhm,
They get support from their families then who understand what they're up against and really value what they're trying to achieve.
mhm. And here, if you can comment on the role of the mentor.
Yeah. Well, I think, it's unfortunately, this is another area where, like many aspects of being an academic scientist or probably even government science, we don't get trained in everything that's in our job description once we're in those positions. And that includes business aspects of running a lab. It's like running a small business, but a few scientists go back and get a MBA degree or something, but most of us just learn by trial and error and too many times error.
Mhm,
And so I think it's the same for mentoring students and postdocs and even junior faculty. We don't get any background. In fact, many of our faculty, when they come in, they've never had any formal training in teaching of any kind, and we have to do better with that. We're here on our campus. We have a special mentoring program when we hire an assistant professor. They join something called the Academy of Research Mentors, where they get a lot of help through symposia and small group learning how to develop the skills that they need to mentor people in their own laboratory. And then we provide senior faculty mentors for those young scientists to help them get through the initial stages of setting up their lab, getting papers published, getting grants funded, and all of those things. So I think this is another positive trend in science, at least from where I sit. There's a lot more emphasis on not just taking somebody, giving them some money, and setting them loose in their laboratory and waiting to see what they accomplish 3 or 4 years later, but really, with the major investments we make in young scientists, we've got to provide the mentoring that they need so they can succeed scientifically and also as an educator. And I think this is happening at a lot of universities in the US
mhm,
because there's been a lot of problems with faculty burnout. I think
mhm.
it's more so on the clinical side in medical schools like where I work that the clinicians tend to get burnout a little bit more than the basic scientists, but it affects all of us.
Absolutely. So now, taking a small break from research. So when things are not working well, what is your way to escape that? How do you reboot your system?
Yeah. Well, when I have free time, there's a few things that I enjoy doing a lot. One is sailing,
Mm-hmm,
and I live on the coast here, the Gulf of Mexico. So I have a small boat that I can take out whenever the time becomes available.
mm-hmm,
I have a small group of buddies who I sail with. It's a great. They're not scientists like I am, so I can escape from talking about science and the politics of the university and
mm-hmm,
interact with people who have different things on their minds. And the great thing about sailing is when you're out sailing, you have to focus a lot on getting the boat to go where you want it to go.
mm-hmm.
There's not enough room, at least for me, to be thinking about work and sailing at the same time. So that forces me to take an escape from that. And I also enjoy traveling a lot. And that's one area where the kind of research I do has given me a lot of great opportunities over the years. I really enjoyed when I was younger taking my children with me on field trips.
Hmm.
And my wife also, she still goes with me on some trips. But so I think that's one way that scientists who do field work can engage their families and have more time with them
Hmm.
by involving them in the work to some extent. And I also enjoy photography, which fits in well with traveling and field research. And so, anyway, those are some of the main things. I also enjoy music. Don't
Hmm.
have quite as much time to do music as I used to. So that's unfortunately that's often on hold as far as performance. But I always enjoy listening to music.
Nice. So now we are walking towards the edge of our conversation. So if you can say something about the role of family and friends, you being a brilliant researcher,
The role. What was the second part of the question?
like for a successful researcher, what is the
Yeah,
contribution of their family and the friends in
yeah.
anyone being a researcher?
Well, I think that, regardless of how efficiently you work and how much help you get with trying to balance your family life with your professional goals, it's always very difficult. And I cannot imagine not succeeding without a supportive family that, especially in the early stages of someone's career, recognize that they're just going to have to put in quite a bit of time to succeed with their program. And again, I've been very fortunate. My wife, since she finished her training in family medicine, she's never worked more than half time. So she had extra time to with the kids. I put in as much time as I could with them. I always made a point of going to their activities, whether they be sports or in the theater and things like that that they participated in it. But there are times when I simply don't have as much opportunity to spend with them as I'd like, and my wife really makes up for that. And my kids, I think, also recognize, especially since I've had the opportunity to take many of them on trips to endemic countries, that I think they recognize that what I do is important. And so they cut me a little bit of slack when I'm gone sometimes on a field trip and things like that. Um, so again, I think that the situation has improved, but I still cannot imagine that very many young scientists will succeed unless they have supportive families who recognize that there are just going to be some times when they have a grant submission deadline or a trip plan that they don't have as much time as they'd like. But in the long run, I think the other thing that I've experienced, fortunately, is that you become a lot more efficient as the years go along at getting your work done.
Mhm.
And you learn how to say no better over the years when you're asked to do some things by the administration and your university in my case. And I think it gets easier as time goes by. You learn how to use your time more efficiently, and that frees up more time for your friends and your family.
Great. It was great having you at this platform. And now the final part of this conversation is the word of wisdom. So researchers, you can give word of wisdom to PhD, postdocs, early faculty, and
Yeah.
faculties for them, please.
Well, I guess if I had to give one piece of advice, looking at my own career, I ended up doing things that I never would have imagined at a younger age. And I really stumbled into opportunities that turned out very well for me. And I think there aren't a lot of people who can decide when they're a young child what they want to do for their career and succeed in that. I think most of us have to take opportunities that come our way, often by chance, and be open-minded that, well, maybe this is something that'll turn out to be more interesting than I recognize.
Mhm.
And so be open-minded, take advantage of opportunities, and I think most of us scientists just have a general curiosity, and there are lots of different areas that could make us happy.
Mm-hmm.
for our careers. So I think most people can do well if they're flexible enough to take that kind of a strategy of being willing to take opportunities. I never expected for the last 3 years I've been working on coronaviruses.
Mm-hmm.
Coronaviruses have always seemed interesting to me, but I never planned to work on them.
Mm-hmm.
But along came the pandemic, and we have all the facilities. We have several real coronavirologists that helped me get some projects started very quickly and easily. And it's been very fulfilling working on coronaviruses. I'm happy to get back more to arboviruses now that the pandemic's subsiding, but I think it's just another example of taking advantage of opportunities that you would never expect and never anticipate, but can be very, very fulfilling.
Nice. No, I think with this, I would like to thanks you for your time we have spent. And for all the viewers, I would like to say that Professor Weaver mentioned few things like be open-minded, don't stuck to one idea. Always go look for trainings. Either you are taking training to yourself or you're providing the trainings to people or to the researcher on there. That builds your collaborations. And at times when things are not working well, rebooting is very important. And the last and but not the least, your support system, your family and friends. These are the people who helps you to get over the rough patches of research, which gives a lot of them. So this was for all the viewers. And now with permission from Professor Weaver, if our viewers can or the audience want to write it to you for any guidance in research matters or funding, would you like to entertain them?
Sure.
Thank you very much. That was very generous. So with this, viewers, please feel free if you want to write to Professor Weir. He's a very generous man and a great mentor, as you might have just figured out in this conversation. You guys stay tuned for another episode of Researcher Celebrity, and we would like to say a great, great thanks to Professor Weaver to be on this platform with us today.
You're very welcome. It was great to be with you.